if you were looking at this square root of x plus 12, you know that you can never have a negative value in this expression. So you can either just take the x plus 12, or you can take the whole thing, set it greater than or equal to 0, and solve the inequality. If I took x plus 12 is greater than or equal to 0 and solve that, I'd get my domain. The domain here is x is greater than negative 12, so negative 12 is my lower limit. Infinity is my upper limit. There is a bracket, so it's going to include the negative 12. So in the first one here, you have this even index radical. If it's an odd index radical, then it's no restriction. But an even index radical, the expression 9x plus 18 can never be negative, so this has to be greater than or equal to 0. And if we solve this, we can do it by factoring, or we can simply solve the equation. And solving the equation gets us x is greater than or equal to negative 2. So there is our domain when we write it as interval. Our lower limit is negative 2, upper limit infinity, can never include the infinity. The negative 2 is, however, included, and so you get this solution. All right, now I'm going to talk through this bottom row, the bottom left one first. Okay? And what you see here is this is a combination of two different restriction types, right? You have the even index radical. So what we do know is the x plus 8 has to be greater than or equal to 0. It can never be a negative. But it's also in the denominator. And if it's in the denominator of a fraction, it can never actually equal 0 either. So I have to adjust how I wrote this, because x plus 8 isn't just greater than or equal to 0. It can't equal it. So I eliminate that portion of the inequality, and I get my expression x plus 8 is greater than, or x plus 8 is greater than 0. Solve. And so what you can see here is my x has to be greater than negative 8. So it's a negative 8 to infinity. Never include the infinities. And now, because it's in the denominator as well as under the radical, it can't actually include the negative 8 because that would then give you division by 0. You see that there's two different rules that have to be accounted for in that expression. Okay. One, the same exact idea. We take the expression 3 minus x has to be greater than or equal to 0, but because it's also in the denominator, it can't equal 0. So it's just going to be greater than 0. And in working to solve this, if we subtract 3 from both sides and then multiply both sides by a negative, you do have to, when working with an inequality, flip the symbol if you multiply or divide by a negative. So you get here x is less than 3. That means you go from negative infinity all the way to 3. Can never include the 3, or you can't include the 3 here, can never include the infinities. And so this would be your interval.